Let's have a look at factoring trinomials. We're going to use something called the line method, and this is for trinomials in the form of ax squared plus bx plus c, where a is more than 1. So notice in both of our questions today, we have a constant in front of the x squared. And this method, or these trinomials, I call the Toughie ones because the method is a little bit more complicated than the other simple trinomials. But let's have a look and work through it. So our first step is basically we're going to make this line formation here, this little chart, and I call this my line. So this will help us organize the numbers that we need to put in this little chart. And the first step is we're going to write the multiples of the first number and the last. So on this side, we're going to make a list of the factors of 2, which is our first number. And on this side, we're going to make our factors of 3, which is our last number in our trinomial. So let's notice 1 times 2 will give us 2, and 1 times 3 will give us 3. And that's all we can think of. And now we have to take the shorter side, whichever side has less pairs. That's what I mean by shorter side. So in this case, both sides just have one pair, so it wouldn't matter which you chose, but flip one of the sides. So we'll take this side and flip it. So we flip the numbers. Now, we're just writing pairs of numbers that multiply to the first and last, and these are not fractions, but it was tricky to write the numbers in a vertical fashion without showing that. So anyway, what this means is 1 times 2, 1 times 3, and 3 times 1. Okay, so we've done the second step. We've flipped the shorter side. Now the third step is we're going to multiply in a diagonal fashion, and we're going to check to see which two pairs of numbers this time add to the middle number, which is 7. Okay, now if this was a negative, then it would be subtract to the middle number. So that rule still carries on from the simple trinomials. So we're looking for pairs of numbers that add to 7. Okay, let's keep that in the back of our mind. And what do I mean by multiply diagonally? Let's have a look. So I mean like this. 1 times 3 is 3, and 1 times 2 is 2. Now does that add to 7? 3 and 2. No, that adds to 5. So let's check the next pair. So we checked this pair with this pair. Now systematically you go through all the pairs. So let's check this pair with this pair, multiplying diagonally. 1 times 1 and 2 times 3 is 6. So 6 plus 1 is 7. So those are the two pairs that I want. Once you find the pairs, it's nice to circle them. So those will be the part of this solution. And we're going to take those numbers and write them. Now this part's important. We're going to write them in the order vertically downward in the bracket, and they match up nicely. And this is one of the reasons why I like this line method. So these two numbers belong in the first of the bracket in that order. So we have 1x and 2x. So notice 1 and 2, 1 and 2 in the same order. And then these numbers, which won't have our x's because our beginning term is the x's. Our last numbers will just be our constants, and we'll write them in this order as well. So notice 3 and 1, 3 and 1. Okay, and we are almost done. We almost have our solution complete. All we have to do is figure out our signs. And thank goodness this rule still applies from simple trinomials. This sign tells us that they're both the same, and we look over here to see what they both are. They're both positive. So all we have to do is put a plus and a plus, and we are finished. Now just notice, if this was a plus and this was a minus, that means that both signs would be negative. Okay. Okay, let's have a look at a second example, because this one is a little bit harder. As we know from before, when this is a plus, it means both signs are the same. This time we have a negative here, so both signs are going to be different, but all the rest of the steps are going to be the same. So let's try it. Multiples of 5, 1 times 5. Multiples of 12, we have a bit more. Now notice I always start with 1. 1 times the number itself, 2 times 6, 3 times 4, and that's all we have. And now we want to do step 2. Flip the shorter side. This time we do have a shorter side. So this side has less, so we're going to flip this side. Notice if we flipped this side, we would have to flip all 3 of these pairs, and that means we would have 6 pairs on this side. So that's why we choose the shorter side. 1 over 5, we flip that, we get 5 over 1. Now we're going to find the pairs diagonally that multiply and give us a difference of 4. So notice this time, this rule is the same as simple trinomials. We're looking for a difference of 4, but in pairs of numbers as we multiply diagonally. So let's go through and check. 1 times 12 is 12, and 1 times 5 is 5. So 12 and 5 does not give us a difference of 4. So let's carry on with this. We checked this pair and this pair. Let's go with this pair and the next one. 1 times 6 is 6. 2 times 5 is 10. 10 and 6, that does give us a difference of 4. So those are our 2 pairs that we want. And the neat thing about this line method is once you find the pairs, you needn't check the rest because there will not be any other answer but 1. So these are the 2 pairs that we want. And notice if I had kept going, if this wasn't the pair that I wanted, I would check this with this, but then I would also check this pair with this pair with this, and this pair with this. And eventually you would find the matching pairs that you wanted. Okay, so that gives us a difference of 4, which is what we're looking for, the middle number, difference of 4. And again, we're going to write these in the first of our bracket with our x's. 1x and 5x go here, and then 2 and 6 in that order, in the same order that they appear vertically, they go across. 2 and 6 go here. Now here's the new part, or the additional step. We have to check and do this thing which I call determine the sign of the higher number. Is it the inside or the outside multiple? And I call that checking the double chin. And that's a little bit weird, but it helps you to remember. So in FOIL, notice that when we multiply, our inside number comes from multiplying the inside 2 terms, and the outside comes from multiplying the outside 2 terms. So notice I kind of have a double chin here. It actually looks like 2 smiles, but we'll call it, I like to call it double chin. So I want to check which of my chins is a higher number when I multiply. So 2 times 5 is 10. 1 times 6 is 6. So the inside is higher, 10. It gives me a value of 10. This gives me a value of 6. So the higher answer has to have this sign, a negative. So should I put the negative here to make the 10 negative, or here? It has to go here. So the inside term always has the sign here. The outside term will have the sign here, okay? So that means I have to put the negative here and the positive here. So just notice negative and the positive. And now notice when I multiply the inside, I get negative 10 and a positive 6, and that gives me a difference of negative 4, which is what I need. If I had made this a positive, this would be positive 10 and negative 6, and then this would become a positive 4, so that would end up with the wrong sign. So the last thing that you can do, we're all done by the way, the last thing you can do if you want to check your answers is check using FOIL. So if you do FOIL on your answer, you should get your question back. If you do FOIL on this answer, you should get your question back. But when you're writing these on a test or quiz and they ask you to factor, you have to leave your answer like this as brackets. Leave your answer like this with brackets. The checking with FOIL could just be done on scrap paper. Okay, now over the next slide, I'd like to leave you with 4 examples for you to try on your own, and then in a couple of minutes we'll take these up and let's see how many of these you can get correct using the line method that you've just learned.